Okay, the first question on the exam asks you to graph this function 2x plus 1 over x minus 4. I think some of you had it as 2x minus 1. Doesn't matter, it's the same general directions. So the first thing we want to do whenever we see something like this is recognize that it's the family of hyperbolas, where you have a possibility for having a 0 in the denominator. So I'm going to figure out where that cannot be. That cannot be when x minus 4 is 0, which would mean that x is equal to 4. So we have, right away, we have vertical asymptote here at x equals 4. But that still means that it's defined, the function is defined on both sides of the asymptote, just not at x equals 4. So the domain includes all the negative numbers and all the positive numbers except for 4. Alright, so the next thing we want to do is to think about, well, what does it look like in terms of limits? So in order to do that, I'm going to take a look at these two limits here. First, we're going to say what happens as x gets really, really huge. So as x gets really big this way, I'm going to take the positive limit, which means I'm going to divide everything through by the highest power of x. So when you divide through by everything through by x, you're going to get 2x over x minus 1 over x divided by x over x minus 4 over x. Well, we know that these last two, 1 over x and 4 minus x, the limit as x approaches 0 is 0, so we end up with a limit of 2. So what that means is that it approaches 2 coming from this direction. So I'm going to just put this horizontal asymptote, because when you come at it from the negative direction, so as I'm going more and more negative with my x-axis, what's happening is the exact same thing. When you do this, you find out that it still is approaching 2 as x gets more and more negative. So now we can just try to say, well, is it down here and up here, or is it up here and down there, or is it both up or both down? So next, when I put in 0, I get negative 1/4. So I'm just going to plot that point, 0, comma, negative 1/4. So you can see that it's looking like it's somewhere down there. So what's happening is, at least on this side, we know that it's going to be going down this way, and it's going to be going up towards 2 that way. But it's not actually going to cross 2, even though I made it just kind of look like it did. And since that's a single value, then it must be going the opposite direction up here. You need to have both sides of the graph in order to get full credit. Then the next question was draw the tangent line at x equals 0. So I'm just going to draw that right in there. It should have looked something like that. And so it looks to me like this is a negative slope here. And then we're going to just go ahead and find the derivative, which is the bottom times the derivative of the top minus the top divided by the derivative of the bottom divided by the bottom squared. And then I'm going to put 0 in because we want the slope of the tangent line at that point, and we get negative 9/16. So the equation is y minus y1 is equal to m times x minus x1, or y plus 1/4 equals negative 9/16 x. So y equals negative 9/16 x minus 1/4. And again, if you interpret this as a minus, then it would be 7/16 instead of 9/16, but still negative. So that's the answer to number 1. That's what we were hoping for.